and welcome back to another session of Geometry Flipped class. Our session for today is entitled Polygons. Today we are going to learn what polygons are and its special characteristics. Here are the key terms you need to watch out for. We need to know what a polygon is, including what are its sides, vertex, interior and exterior angles, including the diagonal, as well as what convex, concave, regular and irregular polygons are, and at the same time able to compute the sum of the interior angles. Let's start on what a polygon is. I'll give you two sets of groups here and I want you to define what a polygon is. The first group are considered as polygons. However, the second group is considered as non-polygons. In 20 seconds, define what a polygon is. Time is up. Now, how do you define what a polygon is? If we are going to consider the first two non-polygons, it's very obvious that a polygon must be a closed plane figure. Aside from this one, what makes their other non-polygons non-polygons because they are not composed of interconnected straight lines. So polygon is defined as a closed plane figure composed of interconnected straight lines. Let us consider this polygon here, and let's talk about its parts. The straight lines are considered or named as the sides, and the intersection of these sides are named or labeled as vertex. Aside from these two, the shaded green portion is the interior of the polygon. However, the outside is called the exterior. With this, we can say that this yellow colored angle is called an interior angle. What do you think an exterior angle is? Well, if you would say that an exterior angle of a polygon is this black shaded angle portion, it's incorrect. Exterior and interior angles are considered to be a linear pair, or two angles forming a linear pair. So it's not this black shaded portion, but it's actually this part here. Aside from this exterior angle, in this given polygon, we can have 7 more exterior angles by extending each side and locating an angle which is a linear pair of a given interior angle. So here are the exterior angles of the given polygon. Another part of a polygon is a line such as this, which is called a diagonal, and defined as a line connecting two non-consecutive vertices. So we connect two vertices that are non-consecutive and we form a diagonal line. Now, let's talk about the basic terminologies for each polygon here. So here are the names for a polygon with this number of sides. The common is the triangle, followed with the quadrilateral, pentagon for 5, hex for 6, hep, oct, nonagon, and decagon. Aside from this, we also have these names for the rest, and generally, for any number of sides, we call it n-gon. Now, let's try to differentiate what convex polygon and concave polygons are. Here are examples of a convex polygon. The second group are considered as concave polygons. In 20 seconds, please differentiate convex from concave polygon. You may start. Time is up. Now, how do we determine what a convex and what is a concave polygon? When you look at the first three groups of polygons here, when you draw all of its diagonals, all of them are actually located in the interior of the polygon. However, for this next group, some of its diagonals, such as these diagonals here, are located in the exterior. Or in just basic terminologies, when we say cave, there is a forming of a caving, such as those three at the bottom. Aside from convex and concave polygon, we also need to define what regular and irregular polygons are. The first group are considered as regular polygon. The second group are considered as irregular polygons. In another 20 seconds, please differentiate regular and irregular polygons. Okay, time is up. Now, when you look at these two groups of polygons here, they have the same figure, but there is a great difference on their measurement of sides and interior angles. For regular polygon, all sides and all interior angles have the same measurement. However, for irregular polygon, not all sides and interior angles have the same measurement. Let's talk about sum of interior angles. We already know what interior angles are. We need to determine now their sum. We have a theorem for this. The first one is for a triangle. It states that the sum of the interior angles of a triangle is 180 degrees. We need to show that this triangle here with these three yellow colored interior angles must sum up to 180 degrees. Let's use these two simple lines, line L and line M, and let us say that they are parallel to each other. Use the concepts we learned before, and I will give you 20 seconds to try to have the proof for this theorem. Take note, this is a theorem, and we need to prove this before we will accept this. Okay, time is up. Now, when we consider that line L is parallel to line M, we can use 5 of those relationships we learned before, such as this red colored angle is actually the alternate interior angle of this interior angle here. Same as true with this blue colored angle here is also the alternate interior angle of an angle here, part of a triangle. These three angles here, the yellow, the red, and the blue, are forming a straight angle. In short, they must sum up to 180 degrees. Now let us try some values here as a proof. If this angle measures 65 degrees, that means the red one also measures 65 degrees. If this angle here measures 45 degrees, that means the other blue angle also measures 45 degrees. Now, again, the three angles are forming a straight angle. In short, they must sum up to 180 degrees, and we need 70 degrees for that. Take a look at the remaining angles now, which are all interior angles of the triangle. When you sum them up, they sum up to 180 degrees. This is the proof for this theorem. Aside from a triangle, we also have a theorem for a quadrilateral. It states that the sum of the interior angles of a quadrilateral is 360 degrees. Consider this quadrilateral, and in 20 seconds, I want you to find the proof of this theorem. Okay, time is up. When we prove this theorem, we look at it as a simple polygon which is composed of two triangles. When you draw a diagonal, you made two triangles here. And take note that each sum of interior angles of a triangle measures 180 degrees. That is also true for the second triangle at the bottom. And when you add these red colored angles, that is also 180 degrees. When you remove that diagonal line there, they all sum up to 360 degrees. This is the proof for this theorem. Aside from triangles and quadrilaterals, we can also talk about a pentagon and a hexagon. Well, you can also use the same concerns earlier, but I'll give you 20 seconds for that. Time is up. Now let's look at this pentagon here. When you draw two diagonals, you came up with three triangles here. And each of this triangle, with all of its interior angles, measures 280 degrees. When you add these three, you came up with a measurement equivalent to 540 degrees. The second figure, a hexagon, same concept. You can draw diagonals that will form later on into four different triangles. Similarly, each of these triangles have interior angles that sum up to 180 degrees. When you add these four, you actually get a sum of 720 degrees. Now this is the summary. For a triangle, 180 degrees. For quadrilateral, 360 degrees. Pentagon has 540 degrees and hexagon has 720 degrees. If we try to generalize this, how do we generalize the formula? Take a look at the number of sides and the number of 180. From 3 to 1, from 4 to 2, from 5 to 3, from 6 to 4, there is a pattern here. So when we generalize this one, it's just actually we subtract 2 from the sides and multiply it to 180 degrees. This is the formula for the sum of the interior angles of any polygon. Let us try to use this one to get the sum of interior angles of a nonagon. A nonagon is a polygon with 9 sides. Thus, we have 9 minus 2 times 180 degrees, which is actually 1260 degrees. That is the sum of the interior angles of a nonagon. Aside from the sum of interior angles, let us talk about the number of diagonals. You know already what diagonals are. In short, I will give you these 4 figures here, and in 20 seconds, draw as many diagonals as you can. You may start. Time is up. Now, how many diagonals are there in a triangle? When you look at it, there are no non-consecutive vertices for a triangle, and therefore you cannot draw a diagonal there. For this quadrilateral here, you have actually 2 diagonals. How about for a pentagon? Let's try to count this one. We have 1, 2, 3, 4, and 5. Therefore, we have 5 diagonals. And for a hexagon, we have how many? Let's try. 1, 2, 3, and then 4, 5, 6. We have 7, 8, and finally, the 9th one. So we have 9 diagonals. This is now the summary of all diagonals from triangle to hexagon. For a triangle, we have none. Quadrilateral, we have 2. For pentagon, we have 5. For hexagon, we have 9. Let us try n minus 3 because we have 0 for triangle. 3 minus 3 is 0. However, it's not possible for quadrilateral because 4 minus 2 is 1. Let's try to add 2 to make it 2, but it's not possible for pentagon and hexagon. The true formula for the number of diagonals is n minus 3 multiplied to a quotient of n all over 2. When you try this formula for hexagon, 6 divided by 2 is 3 times 6 minus 3 is 3, so you have 9. This is the formula for the number of diagonals. Try this formula for finding the number of diagonals in a nonagon. In a nonagon, you have 9 sides, and therefore you have 9 over 2 multiplied with 9 minus 3. That's 6 times 9 over 2. We have actually how many diagonals? 27. You can try to draw a nonagon and all of its diagonals and try to find out if there are really 27 diagonals. Now, here are the key terms we learned and you need to remember. You need to know what polygon is, the side, the vertex, interior and exterior angles, including the diagonal, as well as the types of polygon, convex, concave, regular, irregular, and the sum of the interior angles. If you were able to view this video, I would like you to comment the following in the comment section of Schoology. You have a corresponding type of polygon. If your name is not located here, probably it's on the next slide. Same thing as last time, you need to view and review this video for you to be prepared for our next class session. You can take all your time in reviewing this video, and most importantly, you can ask for help from your classmates. Now it's a wrap. We're done for today. Please prepare for our next session. We're going to deal with the first type of polygon, namely the triangle. Hopefully you've learned something for today, and I'm hoping that you will take your time to review this video, and hopefully you will gain a better understanding. That will be all. Have a nice day. Thank you very much.